Here we have a logarithmic equation and we have to solve for x in this equation. Okay, when I look at the given logarithmic equation, I have the addition of 3 logarithms on the left side. But I won't be able to simplify the addition of these 3 logarithms. The reason is the base for the 3 logarithms is not same. So only if the base is same for all the 3 logarithms, I'll be able to combine them using the product rule of logarithm. But here the base for the first one is 2, the base for the second one is 4, the base for the third one is 16. So the bases are different. So I need to do something else. So for that, what I'm going to do is, so actually, what number do we have in front of this logarithm? So there is no number. I have to assume there is 1 over here, 1 over here, 1 over here. Okay, now I keep this 1 in numerator and I move this log x to the base 2 alone to denominator. So whenever I move a logarithm from numerator to denominator or denominator to numerator, have to switch the argument and base. So when I move this log x to the base 2 to denominator, I have to switch the base and argument, then I'll be getting log 2 to the base x. Positive, the same thing, allow over here. So I'm moving this log x to the base 4 to denominator, then I'll be getting log 4 to the base x, positive 1 over log 16 to the base x equals to 21 over 4. Okay, here we can try to write each argument of the given logarithms as a power of a prime number. So here in the first logarithm, the argument 2 is already a prime number. So we don't have to do anything more with this one. So we can keep this one as it is. That is 1 over log 2 to the base x. And in the second logarithm, 1 over log, this 4 is a power of 2. So 4 can be written as 2 square. So log 2 square to the base x, positive 1 over 16 is also a power of 2. So it can be written as 2 to the 4th power to the base x equals to 21 over 4. Okay, here 1 over log 2 to the base x, positive. Here in this logarithm, I mean in the second logarithm in denominator, so the argument is exponential. So whenever the argument of a logarithm is exponential, the exponent can be moved in front of the logarithm and it has to be multiplied by the logarithm. Actually, this is a power rule of logarithm. So when I move 2 in front of the logarithm, I'll be getting 1 over 2 times log 2 to the base x. The same thing I can do with this one. So here we have exponent 4. It can be moved in front of the logarithm. Then I'll be getting 4 times log 2 to the base x equals to 21 over 4. Okay, let me continue this on the next page. Okay, let's continue. To add the 3 fractions on the left side, I need the same denominator for all the 3 fractions. So I can find a common stuff in the denominator, that is log 2 to the base x, log 2 to the base x, log 2 to the base x. So we have problems only with the coefficients of the logarithm. So here we have 4, here we have 2, here we have 1. Okay, so to get the same coefficient, what I need to do is I have to multiply the numerator and denominator of the first fraction by 4 and the numerator and denominator of the second fraction by 2. So I don't have to multiply the numerator and denominator of the third fraction because already the 4 is there. Okay, now 4 times 1 is 4 over 4 times log 2 to the base x, positive 2 times 1 is 2, 2 over here 2 times 2 is 4, 4 times log 2 to the base x, positive 1 over 4 times log 2 to the base x equals to 21 over 4. Okay, here now we have all the 3 fractions with the same denominator. So we can take the denominator in common and we have to add the numerators. So we get 4 times log 2 to the base x. We get 4 positive 2 positive 1 equals to 21 over 4. So when I combine these 3 numbers, I'll be getting 7 over 4 times log 2 to the base x equals to 21 over 4. Okay, so in the next step, what I'm going to do is I'm moving this logarithm, log 2 to the base x to numerator. When I move it to the numerator, have to switch the base and the argument. So let me do this. So 7 times log x to the base 2 over 4 equals to 21 over 4. Okay, to get rid of this 7 in numerator and 4 in denominator, I'm going to multiply both sides of the equation by 4 over 7. Okay, so this 4 will cancel out, this 7 will cancel out, 4 will cancel, 7 goes into 7 one time, 7 goes into 21 thrice. So the resulting equation is log x to the base 2 equals to 3. Okay, to solve for x, I have to convert this equation to exponential form. Already this equation is in logarithmic form. So to solve for x, I need to convert this one to exponential form. So for that, I have to move this log to the base 2 to the right side of the equation. When I move this log to the base 2 to the right side of the equation, I have to ignore this logarithm. I have to consider only base 2 on the right side. The value which already exists on the right side will become the exponent of this base 2. So now I have only x left on the left side. So I get x equals to 2 to the third power is 8. So I have solved the given equation and I got x equals to 8.